Yeah. So at this point, we know that we are erasing a coordinate marked as a net. I think we should linearize the coordinates and maybe even make them a set rather than an array. Yeah, let's do it. Let's just do it. So down here where we create a new net, where is that? Or up here where we create a new net. So n dot c is just going to be cy times grid size x plus cx. Times grid size x. Oops. Plus cx. Up here where we merge them, I'll just call it xy. No, we're doing this as a set. cy times grid size x plus cx. I kind of just want to call this gx and gy. Actually, even better, grid width and grid height. Then up here, we do for maybe I could use linearized coordinates in my grid array. Maybe that's the smarter plan. Well, let's finish this first. And then we also need to fix it in the draw grid. Oh wait, no we don't. Oh, yeah. Actually, I think it'll just work if we do this. Oh. Attempt to get length. Oh, yeah. This assertion just doesn't even matter anymore. Whoa. That's not correct. Curious. Very curious. Oh my god, something is dreadfully wrong. Numbnet 0? Oh my god, okay, something is dreadfully wrong. It's probably to do with this. Let's just split up into two lines here. I don't think that's the issue, but... So for just a single net, everything's fine. But when we merge two nets together, things go wrong. Oh my god. Something's gone really wrong. But why? Wait, shouldn't this be saying that it merged two nets together? All right, let's change this back to button P because I am filling the log with stuff. So, merge previous and current. So the X1 is 128. All right, hold on. I need to find like a smaller example of badness. Whoops. Whoops. Well, that seems correct. Let's try it over here. That actually seems right. And so far it seems right. Three nets, that's right. Two nets. One net. So this is 1, 2, 3, 4 nets. 3 nets. Two nets. Oh, okay. Man, what the heck? No, I don't think this is the problem. Yeah, that's right. That seems right. This hasn't changed. All right, we have no choice. Whoops. That's a number of nets due. Okay. Oh boy. Attempt to index global. Oh. Net 1 is just 0. Net 2 is just that. So far, so good. Net 1 is all of that. Seems plausible. Okay, something has gone wrong this time. All right, let's restart. Okay, so far so good. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4. 1, 2, 3, 4. Okay, something. Okay, I think I at least see what the problem is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it includes. Oh boy. 0, 1, 2, 3, 4, 5. It includes that. And it includes 1, 5, 2, 5. Am I printing these X first or Y first? Y for some reason. So we've got 0, 5, 1, 5, 2, 5, 3, 5, 3, 4, 3, 3, 3, 2. So 3, 4, 3, 3, 3, 2. 2, 2, 1, 2. Okay, so we basically just didn't get any of the nets, or any of the coordinates from the net that we merged with. So at least now we know where the problem is. For each of C's coordinates, edit them in the grid to point to P, which I think is actually working. Also edit into P's coordinate list. I think this is what's not working. Oh, duh. Okay. I think this will fix it. So now you can go in here and put this back to like this. Yeah, I think this is working now. Okay, so now that we have linearized the coordinates in that list, I think I want to linearize the coordinates in the grid array as well. I think that's the right call here. Yeah, let's just do it. So up here, we no longer, so I'll grab this because I need it, but we no longer need this. Does log even exist at this point? Yeah, it does. Okay, and then, so for grid, we now want this, which means that this needs to come first. Okay. Okay. Let's also comment out this debug. I don't need it for the time being. Oh yeah, I gotta fix all the other linearized stuff here. So let's just rename this to L for linear. Yeah, okay, so let's just put this back. Well, no. It's because I want to do... Yeah, so local L equals, well, I'll just do it like this. CY times GW plus CX. So Control X. I'll just call this LL just to differentiate it. It's fine. Put this here. And now here we can just do this. And we'll also replace it down below where it should. This is okay, I don't need a special variable for that. So this is L. This is also L. That's L. And that's L. So now here we need now this is interesting. L plus dy times gw plus dx. Hey, wait a second. We don't need to do this. We don't need to do that. We can do better than that. We can actually just edit this neighbors. Where is that? So this is 1. This is GW. This is -1. And this is minus GW. Right? Yeah, of course. Okay. So I'll just call this DL. Yeah, this is fine. Yeah. Whoops. That's okay. That is good. That's good. That's good. 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 Yeah, this might work. Yeah, I think this is working. I would like to, well, nah, it's fine. Okay. Okay, now, now what? Now what? Now what? Now what? Now what? Okay, all of this was to make this function easier to write. Oh, now, at this point, we know C is a net. There are 3 cases. We deleted the last coord in C.C, so we should just remove C from nets. We deleted a coord from C.C, but the net is still connected. We split the net into 2 or more pieces. Thinking. So first, just delete it. I think we can handle all these three cases in a really clean way. Actually, no. The first case is always going to be a corner case, but so first, let us just delete c.cl. Remove this coord from the net and clear the grid 2. Okay. For D in all 1, -1, GW minus GW do. Oh, I know. If grid of L plus D equals C, then run DFS so we don't care about efficiency here because this erasing is happening at most once per frame. So it's okay. And my idea here is to always just construct a new net from what we find in DFS. Right? So to construct a new net from what we find in DFS, we need the list of coordinates, the list of gates, and junctions. Yeah, let's just do it. I think it's fine. So I think inside of a net's list of coordinates, I think we should also keep the coordinates of the gates. Actually, there's no need to do that. I'm thinking. Well, let's not worry about gates for now. This is a hard enough. This is the trickiest part of the whole thing. Okay, first let's actually just write the DFS function here. Actually, I want a tab for helpers. Whatever, let's just put it up here. Find all cores reachable from linear chord L belonging to net N but not including L itself. Scene equals true. So now we will do for D and find myself using this here, so so we'll call that neighbors, and we'll call this one neighbors W for neighbors with weights. Which means that in here, we'll do that. For D in all neighbors do. If, is there a continue? I didn't think so. If not seen D, then D equals true. If grid of, I need L plus D. Scene of C equals N. Ret C. Oh, actually, And now we just call DFS of C and C, I think. Oh. I need this too. Not super efficient, but it's okay. Okay, let's try and test this out. Local, I don't know, just test or whatever, is equal to DFS. Actually, let's do this. If number of nets is greater than 0, then local C equals nets of 1. I think I need C. Okay. Now we will do local R for reachable equals DFS starting from C belonging to N for L in all of R, do assert N dot C of L, right? So we want to do this both ways for L in all N dot C do assert R of L, I think. I see. Assert R of L. Oh. Local. Yeah, I'll turn it into a set here. For L and all R, RS of L equals true. And what the heck does all do if it's, I think I need pairs like this. then give me pairs again. All right, what's going on here? All right, let's comment out these asserts for a second and just do some debugging. I see. Whoa. So that includes 0, should now include 1. And so far this looks right. I think my assertions are messed up. Oh, no. What am I doing? This is right. Okay. 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 I think this is okay. I think the DFS is working. Yeah, okay. Let me just add comments here. Test DFS. What was this? I think this is dump nets. Okay. So now we can go in here, now that DFS is working. But shoot, we need the gates. We need the gates. We need the gates. There's no choice. So we really want to do something like return ret gates. All right. So another thing is here is that so if grid C equals n, then sure, we know it's part of the same net. Everybody's happy. Otherwise, we would need a condition that grid of C is a gate, and that gate is connected to this net. And by the way, connected via the direction we're poking at it from. And okay, so I know how to do it. I'm just going to leave it off for now. I'll put it as a to-do. Check for connected gates to. run DFS and create new net from result. So now if length c.c is 0, then return. We'll do log deleted last chord of net. Remove net from global nets list. The remaining portions will be re-added in the for loop. Below, delete nets C. Okay. This also needs a to deal with gates. Okay, so local R equals DFS of C and I don't know, L plus D, C. Well, actually, in both cases where I'm using DFS, I do want it to include L. Always includes L, even if L is not actually part of N. Actually, why do that? Why not just do it right? If grid of L equals N, if not ret, then if grid of L equals N, ret of L equals true. A little inefficient, not that bad. So now here we'll make a new net from whatever we got here. So now we make a new net. Yeah, make new net from R and return gates. LL. I don't think I need this big comment. Actually, no, it's fine. Let's leave it. And all R do. So here we will do for new net. Add nets and n. And then .g is just going to be an empty list for now. And grid of LL equals NN and then dot C of LL equals true. I think that's all we need. See if there's any syntax errors. Okay. So now we need to know the active tool. So after we draw the map, I want to do I think I want 126 minus 5? 1, 2, 3, 4. No, 4. 4 times length of mode. And as for y, 1, 2, 3, 4, 5, and we'll do 7 just for padding. Print mode in color. Actually, well, I don't know. Color 1. Why not? Oh. Okay. Okay. So now we'll go in here. If button push I want to use tab, but I forget which one it is. Mode equals mode plus 1 mod. need this mode mod. No, modes +1. So if it's 1, it'll stay the same. It'll go up to 2. It'll go up to 2. If it's 2, it'll go back to 0 and add 1. I think this works actually. Hey, not bad. Okay. So if mode equals 1, then do that. Else, do that. All right, moment of truth. Uh-oh. Something gone wrong. All right, let's put this back to button push mode. And let's, I don't know, let's dump the nets maybe. Net 1, just adding to it. Okay, now we go into erase mode. Let's hit it. Oh my god. Attempt to perform arithmetic on a Boolean. What the heck? What have I done here? For C in pairs, n dot C. All right. What did I do? ln all R. R is DFS. Okay, delete the last chord of net. At least that works. Try to erase non-net. Created a new net. Appended to it. Now I'm gonna change the tool to erase and hit it. Just go down here so I can see. Wait, that worked. But how come it didn't log this? Net 1 is now empty, which is not true. Oh man, what have I done? Found neighbor, it got there. All right, let's go into DFS and add some logs. Oh. I think this is my issue. So now if I erase, well, first let's do the simpler case. Hey! Oh, yeah, never mind. Almost seemed like it was working. Oh, the same coordinate was in there twice. Something's wrong with my DFS here. Well. Oh, wait, this is C. That's right. Okay, so at least that works. So if I do this and I erase, oh geez, everything went bad. Found neighbor. Oh hey, apparently we do have one net. But something's gone wrong in drawing it. It's a little hard to read. Draw a net, then erase, and it disappears. Found neighbor, 0. That's correct. We have one net here, which just has 0 as a coordinate. I think maybe something is wrong with how we're writing to the grid array. That's the right. I think it's right. Grid of LL equals NN. I think that's right. That's why. Yeah, this should fix it now. Hey, okay. So now, does it work to split things into 2 nets? Okay, now, do we have 2 nets? Hey! I think we did it. I think we did it. All right, let's just put it through its paces. Oh, actually, let me put this back to this. Now we can erase. So we have 1, 2, 3, 4, 5 nets. Num nets equals 1. Not correct. Not correct. All right, let's try a easier test case. Okay, num nets 1 with 4 things in it. Now let's erase this. Num nets 3. That's right. So one big net with a bunch of stuff in it. One big net with a bunch of stuff in it. One big net with a bunch of stuff in it. Now we have 2 nets. This seems plausible. So, what went wrong before? So now we have one really great big net. Still one great big net. Now we have 2 nets. Now we should have 4. Uh-oh. I've only got 1. Man, I gotta do this more carefully. Okay, let's try doing this. Two nets. One net. All right, let's see if I can get a smaller test case. So one net. One net. 2 nets. One big net. 2 nets. 2 nets. 2 nets. 1 net. All right. Why did that happen? Maybe I can get it to happen with just that. So 1 net, 0 nets. All right, okay, finally we have a good test case here. Add to previous, add to previous. Zero nets, what the heck? Deleted last coordinate of net. Oh, I know why. Oh, I absolutely know why. This was dumb. Yeah. Yeah, I think we got it now. Okay, so this is 1, 2, 3, 4, 5 nets. 5 nets. One net. Okay. So now we can erase some stuff. Actually, let's check the log here. Too many. So this should say erased last chord. I still have one net. Now we should have 1, 2, 3. Yeah. Now we should have 4. Now 3. Now 2. Still 2. Just 1. Yeah, I think this is working. All right. So now we need to do either junctions or gates. Oh, actually, one thing I just want to quickly check here. Yeah, maybe I will draw a little box behind it. Yeah, I think I better draw a box behind it. Rect fill. So txt x minus 2 minus 1. Txt y minus 1. And I don't know, what color do we want? Maybe... I don't think we're using... Oh, we are using purple. So maybe like pink would be good? Well, actually this beige might be alright. This is color 15. Okay, that's not right. Oh, but the cursor should be on top of that, I think. Actually, no. I think it should stay below. Oh. I don't really understand this. Why is this box all the way over here? Do I not know how to use rect fill? Oh. All right. We've gotten off by one error here. Well, there's one way to fix an off by one error, is just subtract one. Alright, what else would look good on top of that? Maybe this color? Color number 3, maybe? Ooh, no. Color number 1 was better. Maybe... Let's try 12, just for fun. It'll kind of clash with the cursor though, but that's okay. Ah, no. I like the beige. What about brown, number 4? No. Horrible. I'd like to avoid gray normally, but let's try it. No. It's not really gray. It's like some kind of dark brown. I don't know. Honestly, this blue was the best, even if it's a bit dark, but that's okay. So yeah, the tool kind of obscures what you're doing up here, but that's okay because you're supposed to be able to like pan around. Yeah, so the upshot of all this now is that not only do I have a easy to draw map, I also just have like objects for each individual net, which makes it easy for me to traverse the graph essentially of connected gates. So that'll make it more efficient to simulate. This might be a good place to call it quits. Let me at least think about how to deal with the gates. I've kind of already thought about it, but there's one kind of point of detail that I know I need to manage, but I haven't thought about yet. Every gate has 4 ports, up, down, left, and right. And I think in the gate object, we do need to indicate what port connects to what net. And likewise, within the nets, we need to say what port of the gate it connects to. Because for example, we could have a wire going like this, and we could have a gate here, for example, but maybe we only want to connect the wire to this port of the gate, like that. And yeah. So we might only want to connect the wire like this to the gate. Maybe the other, maybe the other thing connected to the gate comes from up here, right? Well, I mean, so if it was actually a gate, it wouldn't connect these two nets together. But I think you get the idea. Also, I really desperately need an undo stack. Really, 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 really need that. So yeah, anyway. So the net needs to know what port of the gate it's connected to. And well, that's all there is to it. And then in all of the, like in the depth first search, when we test, hey, is this neighbor part of this net, we'll have a case for the gate to say, are we on port, whatever. So that's kind of annoying because I think maybe what we'll need to do to try and keep that nice is up here in the neighbors, maybe we'll have one, well, we could use neighbors W and index the ports with these, with the weight. I don't know, it might be better just to have like something like this, like it would be neighbors P, and if we're accessing it from the left, we'll call that port 3. If we're accessing it from the top, we'll call it port 4. If we're accessing it from the right, we'll call it port 1. If we're accessing it from the bottom, we'll call it port 2. So like the second number says what port to use. I think that would work. Now what about for junction? A junction is the exact same thing. It has port numbers. So yeah. Okay, so we worked out the port numbers. So now it's not so much that nets connect to gates, but nets connect to a port, and ports are grouped by 4, belonging either to a gate or to a junction. Or to say it differently, I don't really plan on making ports their own like object. What I intend to do is, it's like kind of like a pointer between a net and a gate is tagged with what port belongs to it. And a net could point multiple times to a gate and connect to multiple of its ports. I'm not really sure why you would do that, but you can if you want. Okay, yeah, maybe I should write this down for myself so I don't really forget. I guess I'll just call this notes for our next time. Every pointer between, I'll write it as like, I'll write it like this, to or from, and well, oh no, I'll write like this, between a net and a gate or a junction. In both pointer directions is tagged with the port num on the gate. questions to answer. How can we plug a gate directly into a gate with no wire drawn? One idea would be use a net anyway. Yeah, one idea is using that anyway. The reason to do that would be because when I do the simulation, like, that's how I do it. Other stuff. DFS needs to understand connectivity through junctions. What time is it? Oh my god, it's almost 11. What the heck? Alright, so DFS needs to understand connectivity through junctions. Like, the actual simulation logic is dead simple. For every driver, so sim loop, for every driver, currently this only includes gates, set driven nets state to high. Note if multiple drivers connect to same net, the net's value is the or of all the drivers. Then for each, just draw the scene, basically. Draw the scene, taking care to highlight gates, but just to highlight stuff properly. Compute next state for all storage elements. Currently, this is just gates. Cycle of storage. wonder if gates should have like an enable so that they can act more like a flop. I mean, or we could just have like a separate, because I was thinking of having a delay element. It would basically be a configurable shift register with an enable. The input would always be on the left-hand side, the output would always be on the right-hand side, and the enable, I suppose, would be the OR of the top and bottom connections. And you could configure, yeah, so we do need delay elements. Delay elements are going to be a little bit more. Well, no, they won't be, because here, because if I go with the rule that the input to a delay element is always on, I mean, I could even, you know, could even draw it as a repeater, and basically you would have like some amount of storage in there, right? And you could set the delay, and by setting the delay, it would change the length of the, so I guess the storage would maybe look like this or something. And, or maybe it's just always 4 cycles. No, that's stupid. And, you know, we have enables that you can use to latch the output. So, I mean, this is the rest of the space we have. We've got this 1, 2, 3 by 16. We've got these 48. If I use these 48 just for delay elements, like, so let's think about this for a second. Because, again, the reason why I'm making separate tiles for all the possibilities instead of drawing it every time is not because it's easier. It's actually harder, in my opinion, to have to draw these tiles and figure out the tile offsets depending on the state and all that crap. The reason is because it makes it easier to save the state into a cartridge. Rather than having to, well, it's not that it makes it easier, but it just makes it like more intuitive. It means that like if I save the map, I can actually, it means I can edit the circuit in the map, right? I don't have to edit it using the actual like game itself. Like I could draw it in the map if I wanted, or I could see what I saved in the map and browse through it. Like, anyway, I think it makes sense to do that. So anyway, going back to this, so you know, we would have, I think here we would just have to densely pack them. We won't be able to get away with it, but so like then, so we have 2 possibilities for the single cycle storage. We have 4 possibilities for the 2 cycle storage, and then depending on how much space we have here, we'll see if we can get up to 4 cycles of storage. So now here it'll be like that. And like for each of these, we may wish to show that it's latched if any of the latch inputs go high, right? You know, so Actually, no, I want it to be like this. Right. So that's 2, 4, then we'll put 1, 2, 3, 4, 5, 6, 7, 8 here. Then we can put 16 of them here. But then we won't have enough room to show the latched version, right? Because so I don't really know how I want to show the latched version, but you know, maybe something like this. I don't really like the gray there. Maybe that's not bad, actually. Or, I mean, what if we just turned the whole thing a different color? Or what if we draw this bar here a different color? Like we could just draw it red. I think that's pretty clear to show that it's latched, right? So yeah, we can't use the second half here because it'll bleed into the map. I do have some space up here. How many spaces do I have? 1, 2, 3, 4, 5, 6. So here I'm thinking of using 12 plus 16, which is 28 times 2 is 52. I have 48 plus 6. I can barely do it. Like if I take these and put them up here, then if in here, whoops. I do the latched versions. You know, I'm starting to think my issue when I do these projects is when I'm taking a long time and overthinking, maybe not overthinking, but just like, you know, really thinking about something that seems really minor, I just start to like, I don't know, like beat myself up and go like, no, you're overthinking this, you know, take it easy. But no, this is just how I do things. This is just how I do things. I don't know what else to say, right? Okay, so this uses up 8 slots, and then, oh, right. No, I don't have enough room if I want to show the latched version. I don't really need a second one for the latched version, right? I really don't. Let me just get rid of these. I really don't. Like, the user will be able to see that it's not moving ahead, and they'll know, well, I don't know, because in Minecraft, when you latch a repeater, like it actually shows a bar across it. I mean, I'm borrowing their design quite a lot here. I really don't like this gate design. I still need to figure out what I'm doing with this. It just looks awful. I don't like it at all. I think this second color scheme here with the brown and orange is just not working. The junctions are good. I like the junctions. But yeah, these brown gates are just like abysmal. It's hard to even tell that they're gates. Let me just experiment with something here. What if I use this as a gate? Yeah, I see. I'm back to this again. Man, this is like an unsolvable problem. I just can't find a nice gate design. Like, I don't think it's an accident that I landed on this. Like, this was after me fighting with it for a while. But I still don't like it. I still don't like it. I mean, maybe it would be better if I used the same purple and red color scheme here. But like, if you just saw like the purple here with a bar like that, like, would you recognize it as a gate? Yeah, maybe actually. Well, no. Because you need to, like, when you wire out this gate in, you need to be able to visually see that. I mean, actually, this bar does work to kind of indicate a driver. I do think it works. Oh, whoops, I didn't mean to do that, but like this does work to indicate a driver. It means that whatever, if you wire another driver on this, it won't feed back into that. But you also need to see that, like, you need to see that these three are loads and will never feed back onto the wire that plugs into them. And you need to see that this is a driver, which means that it also won't feed back. It's also how you can see that it's a gate. So how can we better show that these terminals here are just pure loads that'll never feed back? Whoops, I have the wrong tool out. Like, what if I notch them? Or like, what if I do this? It's hard to see. Actually, let's try that out. What do I have? I've just got this one here with the negator on the output. So let's just take a quick experiment with this one and see how it looks. And actually, let's go back to the purple scheme. Purple and red scheme. So let's just try this out and see what it looks like. Oh my God, no, that's terrible. Wait a second, actually, hold on. If I show that these ones, actually, what if I try this? That, it might be better. Hold on, let me see what the purple one looks like. Still a little goofy looking. If that doesn't look phallic. I mean, the gap idea is still like pretty good. Whoops. So like, I think the gap idea is still the best. Let's, let me just experiment with this tile here. Like this, yeah. So like, if I put a negator on this one, what does that look like? Yeah, actually, you know what? Maybe that works with a gap. And like, or like, what if we, no, I think the gap is fine. Because here, like, well, I did kind of like this a little bit because it kind of looks like it's sensing it, you know. What would be really good, oh, actually, no, never mind. There's just not enough room. All right, 1 second. And yeah, it's like it's pretty easy to tell. Oh my god. It's pretty easy to tell the gate apart from, let me just quickly go over here and color this red. It's pretty easy to tell the gate apart from like this symbol here, like this complete attachment symbol. Like, I mean, that and that look nothing alike. Well, okay, they look a little alike. I mean, let's be real. But honestly, I think it's better than what I had before. I think it's a lot better than what I had before. Actually, maybe I could do something a little weird. Like, what if I put in like this? Oh, I gotta draw it here too. These little floaties here. I mean, these will get covered by the cursor, but that's okay. It's a little busy. It's a little busy. Okay, what if I try like this? Because now we have a pretty good visual distinction. Like, I don't think anybody's going to confuse the connect all four. And then, you know, we could always show the negators here, you know, like this or something. Here we've got two negators back to back, but it's really hard to see. Maybe the output negator should look like this, and the input negators can look like that, because you'd never put two inputs together. Let's draw the purple ones here and see. Oh, but right, of course, if there's a negator here, then this would have to be like that. We can make the negator a little wider on the output. It's just a negator, which means that here we would have that. You know what? I think this works. I think this is okay. The wider base makes it look more like it could be like picking up, like, you know, like sensing. But the fact that there's a physical gap, or in the case of having a negator on it, in the case of having a negator on it, for example, it still looks separated. Oh, I drew it on the wrong one. It still looks separated. And yeah, I think having the output negator drawn like that helps a lot as well. Well, actually, the output negator looks a little weird. Like, maybe it would be better if I did it like this. Or maybe it would be better if I just used the whole side. Yeah, actually, that's pretty good. The whole side for the output negator. Yeah, I think I'm sold. I think it's still a little weird, but it's definitely better than whatever I was thinking with this. So yeah, let's just go ahead and make the change. This is going to be a little tedious, but you know, this is about all I have. This is about, what am I trying to say here? This is all I have brain power for today anyway. Actually, question, should the input negator, should it look like this? No. I do think it's fine to have it like this. Let's just see what that looks like. Yeah, I think that's fine. I think it's fine. So yeah, let's draw it like that. So now this has just that, just that, just that, and now both of these, and now both of these, both of these, both of these. Also, the fact that this negator takes up the whole bar, I also like how that helps distinguish the output side from the input sides. And there's already enough distinction, but I like how it helps. Ooh, what if we do it, oops. What if we do it like this? Nah, I think it's fine the way it was. Okay, now we need groups of 3. Oops, not like that. Okay. And this. Then this. And then finally, all of them. Bam, 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 bam. Yeah, because here when I look at this, I see, yeah, there's a negator here, there's a negator there, and a negator there, and no negator on the output, but there's a negator on the input of this one, and they look fine. Yeah, I think this is good. I think it's better. I think it's better. So, yeah. Now let's go in here and do our little trick, not here, here. that we can color them all red. I need this x0, y24, x127, y31, y0, y32. Okay, good. And now we'll go in here. So maybe I can get away with it like this. Yeah. I'll fix the negators in a second pass here. And then now what we can do is go here and fix all of these. I think I like this. I think I like this a lot better. Oh yeah. Yeah, that's way better. Way better. So now here, we can do all of these. And maybe we just only go up to, actually maybe we should use purple here. Like, why introduce a new color when we don't need to? And yeah, so maybe we just don't allow 4-element shift registers, or 4-element, you know what I mean, 4-element shift registers with enables. Maybe we only go up to 3. I mean, if you want 4 elements, put 3 and 1 in series, like, you know. It's just a limitation. It's just, this is the way it works. Nothing wrong with that, right? Then we'll still have a row left to do things like, I was thinking about having like vias to go through different layers, or I was thinking about having splitters. It would be nice to have some custom inputs and outputs, like splitters and joiners, I mean, when I say splitters, like in Logisim. Because it would be nice if you could wire like an 8-bit bus without having to wire like 8 buses. Although we can. Unlike in Minecraft, like you can, oh, whoops, that's not what I meant. You know, you can have like, whoops. Shoot. I really need an undo. I desperately need an undo. Yeah, so like you can do this for a 4-bit bus. Whereas in Minecraft, you would have to space them out at least by 2, which is really just awful. Right, and let's just connect all these together. I mean, at least erasing is fast, but whoops. Yeah, I really need an undo. But how could I? Well, okay. Well, no. To copy the whole state and push it onto an undo stack, although we definitely have the memory for it, I think going through a whole like 128 by 64 array and deep copying it, I don't think we can do that in a frame. So maybe we'd only do it like every 10 frames, or only do it when the user makes an edit, or for every change we make. When I say change, I mean like changing an individual pointer. Like, no, that wouldn't work. Well, okay, I really need an undo, but yeah, the fact that it connects stuff together when you don't expect it. I view that as a problem. Because, I mean, I understand what's going on because I'm the one who coded it. And if I put like a textual explanation in the game that says, hey, by the way, every time you draw a wire, it'll try to connect it to the last place you put a wire, like that kind of helps. Maybe if I circled the last wire position so that the user knew what was going on, or something like that. Or maybe if I add like just a times delay. No, I don't think a time delay would be any better. Maybe if we only auto-connected vertically if the last connection was done vertically. In other words, I just keep going in a straight line, and if we move to a different line, like don't connect, but then connect anyway when the user goes a second time. Or it'd be nice if maybe like the Z key, like auto disconnected, or if like the cursor, yeah, maybe if the Z key was like a modifier on the current tool. Oh wait, no, that doesn't make any sense. Well, no. Maybe if we do something like, what does Z do right now? I don't think it does anything. I wired this up to Q for some reason, even though Z was free. So if Z switches tools and X applies the tool, there's really no leftover keys, or buttons, I should say. I think the only solution is to circle the last wire placed. I think that's the only solution, because then at least, or actually maybe we could have like a ghost wire. And this wouldn't be part of the map. It's just, it would basically be like a modification to the cursor. Yeah, yeah. Okay. Let's do that. Let's do that. I like that. And also, let's change this to Z. I don't even know why I put that on player 1 controller. So down in here, caps lock, Steve, caps lock. And I need a ghost wire, so what I will do so let's see, over here, where's my LW? I'm just gonna put it twice, like, actually no, all the globals are in the same place, right? And so yeah, this is basically like a modification to the cursor. So what we'll do is we'll draw the corresponding like single wire segment here, but we'll draw it in pink, so we'll use a P alt for that. So let's do something like draw helper stub to hint which way wire will connect if no equals 1. If so, let's do local D equals last wire y times GW plus last wire x. So we'll just call this last wire linear equals that. Local C linear equals that. Local D equals C linear minus last wire linear. Local TLUT tile lookup table equals 1 equals, so what does 1 mean? 1 means that to go from the last one to the current one, it means we go to the right, so we need the one to the left. This is confusing. So here I need 35. equals. So that means to go from the last one to the current one, we need to move down. So we need the one that goes up 36. So by process of elimination, we need the other horizontal one. By process of elimination, we need the other vertical one. Local T-no equals T-lot of D. If T-no, then pal, I want red, which is 8, to become pink, which is 14. And then I will do spur of T-no, wait, what's the order for spur? Yeah, tile number CX times 8, CY times 8, and pal 8. Whoa, what did I do? Oh, why did I do that? Oh, I got confused. Cursor just means the Pico 8's cursor, not my cursor. Okay, let's try it. So, oh, cool. So cool. I can't believe this works. Okay, yeah, this is great. It does do it. Okay, yeah, let's only do that if it's blank. If mode equals 1. So let's just do this because it's useful. Might be useful anyway. Mode equals 1 and grid CL type equal net. Because I think for cursors and junctions, it'll also be helpful to see. Yeah, this is great. Oh. Oh. Okay. Right. I got my Z and X backwards. This is kind of bothering me. So I want this to be that, and I want that to be this. So now if I wanted to draw by underneath it, I'd be like, oh, uh-oh, it's going to connect. So I can do that. Yeah, I think that's a pretty good solution. No, I do need this. I do need it. Yeah. It's fine. Like, it's fine. It's fine if it overlaps it. Like, it looks a little weird in certain cases, but I think it's okay. Actually, we could fix that pretty easily by putting the hint underneath instead of on top. So we don't want this. Just keep that. And all we'll do is we'll just do this before we draw the map. Whoops. I guess I need this up here. Yeah. 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 Let's save that to Git if I can remember how to use Git on this computer. Projects, carts. Oh man, where is the carts folder? App data roaming. What the heck? Roaming, Pico 8. Carts. I probably have a bunch of stuff here on Git status. Yeah. Oh wait, I have edits on Mahjong. Oh, it's just a comment change. Anyway, oh wow, I can't believe that worked. Okay. So yeah, I have it saved into Git now, so I'm a little bit less scared that I'll just lose everything I worked on. Yeah, so we solved the, little problem there in a pretty nice way, if I do say so myself. So what else do we have on notes for next time? Oh yeah, this idea about the port. Yeah, this question about a gate plugging directly into a gate or a junction, or basically any non-wire plugging directly into a non-wire. That remains to be seen. I think I would want to make it a net to make the code consistent, but then we would really have to be careful to check for these special case like invisible nets when we're adding and deleting gates. I gotta say though, you know what? Another big problem we solved was that the gates looked bad, but I actually am really pleased with how they look now. I think it works really well, or it works as good as it could with what I have. And I even started designing this delay element here, although I'm not a big fan of the gray. I kind of like this color better, although this kind of clashes with the color I'm using in behind the tool on the top left there. But this color is just nicer. I just like it more. So yeah, I think we made a ton of really good progress. I kind of want to keep working on it, but it's also 11:45, and if I start trying to do something tricky, I'll probably just get it wrong and have to redo it tomorrow anyway. But hey, it's the weekend, and it's only Saturday. Like, I can work on this tomorrow. So nice. Yeah. So yeah, for this, I think we are going to have invisible nets, and we'll just have to be careful about it. Yeah, DFS needs some upgrading, but this is not a big deal. For the sim loop, like this is it. Like that's all I need. I could even use a lookup table for the gates, depending on, so like for the gates, what I'll do is I will read all of their neighbors, well, not all of them, the neighbors on the left, bottom, and top. And I basically just need a 7-bit lookup table between the state of the 3 inputs and the state of the negators. And like that's just 128 entries. We got tons of memory. Like who cares? I got tons of space left in the cartridge. I still have like 5/6, even more than 5/6 of the space. So let me just write this down then. Other stuff. Use 7-bit, essentially 7-bit lookup table for gates calculation. Select bits are inputs and negators. What else do we need? We need like things that the circuit controls. Maybe there's an opportunity with sound. Or that lunar lander idea. I had an idea that like your job would be to create a circuit that should pilot a lunar lander, but I think that would be really difficult. Most people would get frustrated. I would get frustrated. Like, you know, even if you don't do like a full complete like CPU, like if you want to do any kind of like analog stuff, having like multi-bit buses to represent values and doing arithmetic on them would just be really miserable. Oh, that makes me think. Copy paste will be crucial. All right, I'll be right back. 1 second. I still want to work on this though. Like, let's finish up. I still don't feel like I've gotten all the ideas out. Once I feel like I've gotten them all out, then I'll stop. Let me find some interesting soundtrack to put on. Okay. Well, maybe not crucial, but is important. You know, it'll just make using the thing so much nicer. Really need an undo stack. What are some other things that it can control? I mean, Quinn came up with an idea earlier, which is like have challenges, you know, like Shenzhen IO, which now that I've mentioned it, I really want to play it, but not right now. Not right now. I'm way too tired. I mean, would be cool to have a CPU chip to plug in that you could program. Can we do multi-bit buses? Like if we think about an adder circuit, like a 4-bit adder. Let me see if I can draw one. I won't worry about the timing or this scheduling here, but so let's say, you know, let's say our bits come in through here. And our other, let's do 3-bit. So let's just do 3-bit operands. Let's say our other one comes in through here. Like even this is a challenge. Let's do a 2-bit adder just so I can even finish it. Oh man, I gotta think about this. Alright, let's start with a half adder just so I can figure out how to do it with these ridiculous logic gates I have here. So the sum is the XOR. Oh yeah, I need a half adder, so that means I need 3 inputs. So the sum is the XOR. How do I do XOR of 3? I need more than one gate for that. What does XOR look like with just 2 gates? Wait, how do you... Oh man. An XOR is or and not and. So I need one gate here, which is going to be the OR of these 2 inputs. And then we need to do an AND of these 2. So an and is essentially this. And actually, it's going to look like this. And then we need another third gate here, which is an AND gate, but with a negator on this. Which I think is this. Except this one. So this is the XOR of these two. But to do an XOR of the 3, I need another XOR gate over here. Yeah, this is what I mean. Like, even just a single like half adder. I know this is a full adder I'm doing, but even just like a full adder is kind of involved. Also, I kind of, whoops, I didn't mean to do that. I kind of want to change this for one that doesn't have a negator on the top. So this one, yeah. And I kind of want to change this one for one that doesn't have a negator on the bottom. I think it's this one. No, not that. This, I think. Yeah. Actually, I really like how these gates have turned out. I'm really pleased. Yeah. I wonder if there's a more like compact way of doing a 3-bit XOR. Oh, wait, no, this is not right. No. This would be on. If it's the OR of these two things. But then we need the AND of these two things. Which is, I won't use this one, I'll just use the one that has the where is it? Did I forget to draw it? Oh yeah, this is wrong. This shouldn't have one on all four. This needs to be fixed. Oh, but actually this one would be off. Yeah. So then we would have another AND gate here. So So the output needs to be negated, but we only want like this, except this would be off. Oh no, this is right. Wait, no, how could it be right? So this is an or. Oh, no, but we need not and. Or no, we need this gate. So this is the and, that's correct. This is an or, that's right. This is an or, that's right. This is an and. Oh, this is wrong. Oh, no, this is right, yeah. This is right. This is an and. Then here we want this and not that. So here we want this. So there shouldn't be a negator on that, but there should be a negator on this. Like that. Yeah. I mean, the simulator would have figured out the state for me, but... So actually this is wrong here. The negator is supposed to be on the other one. But that actually means it would be on, right? Oh, no, it's that and not that. Yeah, this is right. This is right the first time. So it's, wait, no, is that right? We want this, which is the or, and not that. So actually, no, I had it right the first time. This one. And then this one should also be that. Yeah. So that's the sum. Now we need to figure out the carry. And the carry is 1 here. Is there a better way to do a 3-way XOR? Like, can I do it with less than 6 gates? Let's not forget here that the gate delay here is 4. Can I do it with a better gate delay? Let's manually simulate what happens if I change this to off. It is kind of nice that I can just do it like that. And so then what happens with this one? It's still on. What happens with this one? It turns off. What happens with this one? It turns on. What happens with this? It turns off. So now this turns on, because this 0 going through negator puts this on, which means this has to turn on, which means, or off, I mean, it means this has to turn off, which means this one turns off. And the final output has to be on. Not too bad, huh? You know what? The more I play with this, the more I already liked it before, but the more I like these little gates, the way they look. Oh, one thing I didn't check though is how do they look when you put the cursor on them. Let's just test that out here with, I don't know, this one. Well, it looks a little busy, but you can still tell what it is. You can see all the negators. You can tell it's a gate because it has this pattern of 4 dots in it. Like if there wasn't a negator on here, you can still tell. It's a little hard to see the negator, but it's okay. And, you know, even if we had a negator on here like that, like, yeah, you can still see everything you need. So yeah, that's a success. I'm starting to really like this. I'm starting to really like this. Now I'm really scratching my head here. I'm trying to think, like, how could I do an XOR with less gates or maybe like a smaller delay? That's interesting to me. So here I did it by saying XOR is equal to A or B and not A and B. But what if we try A and not B, or not B and A? Because then we can use our built-in rule that drivers just get forward together. In fact, I guess, you know, we technically don't need this OR gate here, because we could do it like this according to our rule, but yeah, you know what, let's do that. I mean, why not? Oh wait, does that work? I don't think it works. No, I don't think that works. Because this here is the and of this and that. But if I connect them blindly here, this wire is no longer that. It's the or of these two things. Same thing would happen here too. One question to answer. Actually, hold on. Another question is, can we do analog like in redstone rule? Negation does val equals max minus val, or does max of all inputs. Change this for like a number. It'd be like 255 or something. So that should be backwards compatible. Like if I do an AND by doing the negation of the OR of both negated inputs, in other words, using the De Morgan formula, I think it would work. Or actually, I mean, negation just does negative. And like 0, yeah, actually. So logic low is if the value is 0 or negative. Oh, no. We do need to do like, yeah, because we want 0 to be logic low. And if we do negative 0, we want that to be high. So we do want like something like 255, or like we could do max num, for example. So like max num minus n, and then or is max of n0, n1, and so on. I don't know. Maybe. And I guess another idea here, this is the last idea I'm going to write down. What to do for music. Need probably 2 or 3 songs to loop for ambience. How do you spell ambience in English? Oh, it is with an A. Oh, they're both accepted spellings. I'm actually not so good at writing songs on the Pico 8, or just in general, but I kind of have a hard time on Pico 8. I could steal something. Oh, dude. Oh, dude. What if we used the Django Mahjong OST? I'm kind of getting sold on that. I almost just want to try it. Hold on, let me pull it up. Man, how would I recreate this in Pico 8? It would not be easy. I'd have to simplify it. Yeah, okay, enough. I've decided I'm gonna pick the simplest songs I can from Django Mahjong and try and put them in. But that's like far down the line. I got more obvious things to do first. The obvious one is to simulate the gates. The simulation part is what's easy. The hard part is the bookkeeping of the like ports and stuff, and the invisible nets in between 2 gates that are back to back that don't actually have like a wire in between them. The invisible nets is probably going to cause a lot of bugs and headaches. Well, actually, so if I go into the simulation loop here, right, for every driver, I wrote down here, set driven net's state to high. But, you know, why should it be a net? You know what I mean? Like, if there's no net connected because it's back to back with a gate, then it just doesn't do anything. But then here, when we compute the next state for all storage elements, like when we're looping through the gate's neighbors, we can have a special case for one of the neighbors being a gate or a junction. Now, if it's a junction, like we could have a bunch of junctions back to back, and we may have to like traverse the whole graph there, but it wouldn't be like an expanding DFS search, because for the junctions, every input, like like for the junctions, there's no like branching. You see what I mean? Like there's just straight lines, so you would just be following a linear path back to potentially a net. So I guess in the case of junctions being back to back, for their ports, they would just say they wouldn't have anything in the connection. But when we are computing the junctions, like state, or like when we're deciding to draw the junction, like we will have to traverse it. That's like, fine. I think it's fine. I mean, we could cache what net it's connected to. The only reason we would do that would be if we're so tight on performance that like the extra 2 cycles or whatever matter from caching. Well, we would gain more than, well, I don't know if we would necessarily gain that much, because it costs code to maintain the correct cache in the junctions, but yeah. I think this is sometimes it helps to plan things. I think this is a case where trying to plan out exactly how I'll deal with the invisible, or back-to-back gates or junctions. I think that's a case where it'll just be clear how to do it as I implement it. Yeah. But I'm really thrilled. I'm really thrilled with how these gates are starting to look, like how the circuits look. Like this to me looks really cool. As for these storage elements, I think they need a little more work before they look as nice as this. But we could experiment with the color. And now I'm just goofing around here. Like I'm not getting any work done. But it's like I say, it's my own damn project, so don't get on my back. Like we could use. Oh no, that's not good. The gray is just a little too dull. I mean, maybe I just don't like the shape. It looks a little like, because these shapes look nice and crisp and clean. But this one just looks kind of like blobular and ugly. Whoops. Like maybe what I need. Maybe I need to do some anti-aliasing on it or something. That did not help. Maybe if I do it like this. That also did not help. Anti-aliasing doesn't really make sense anyway on a display like this. Also, this color I just realized is not going to look that good on a white background. Yeah, that's just not enough contrast. That is not good. I mean, maybe no, even the gray. What if I try this dark gray? Maybe the brown or the orange. Let's see what that looks like. Actually, I haven't thought about what these gates look like on a white background, but I'm sure it looks fine. Whoops. Yeah, it looks fine. It's fine. As for this, though, you know what? I think I know what's bothering me about it. The orange is like decent, but no, it's a little bit too. What if I try pink? Actually, the pink isn't bad. The pink isn't bad. It looks worse against the black, but it actually looks pretty decent against the white. I think what's bothering me about this design is that the ends. Man, I don't know what's bothering me about this design. It's just, I don't know, I don't like the way it looks. Like, maybe I'll just have to like keep going back and forth to it. Like, maybe I'll just have to keep editing it like I did the gates until I'm happy with it. The gates have really turned out nice. I'm really pleased, but this, on the other hand, like, I don't know. I need a more inspired idea. Man, I'm still hungry, even though I had quite a lot to eat. I don't know why. Maybe I'm just running my brain too hot. Alright, whatever. Enough of this. It's time to stop.